All right, in this video, we're going to take a look at how to graph variations of tangent and cotangent. All right, so remember with the tangent graph, we found that you got one full cycle, a complete section of the graph happened when you were in the range from negative pi over 2 to pi over 2. Okay. So let me just draw that unit circle one more time. Oops, that's terrible. Try that again. So let's think about that unit circle with those ordered pairs. Okay. All right, and so remember what happened was when you're at pi over 2, tangent would be at pi over 2, the tangent would be undefined. Okay, and same would be true here. Okay, that would also have an undefined tangent. So your tangent graph had two vertical asymptotes, and it had vertical asymptotes after that every pi. Okay, so the period for tangent was pi with vertical asymptotes at negative pi over 2 and pi over 2. So we're going to have vertical asymptotes like this. And then I know the gist of what it's going to look like, but it just helps to remind you that when you're here at 0, okay, so let me put this in again. So when you're at 0, the tangent is going to be 0 because it's 0 over 1. When you're at pi over 2, it's undefined. When you're at pi, okay, can't see that real well, but pi, the value is going to be 0 and so on. So we don't need to go a whole lot past that because we're really not going to go that far. But I thought I'd go ahead and remind you kind of what happened in those normal ones we use. We don't typically use these for tangent because a full cycle of tangent, one complete section of tangent happens between negative pi over 2 and pi over 2. Okay. All right. So really what helps is to know that here you're going to be at 0. And then to split, actually, instead of doing the usual one, see, the usual ones give me a little more information. I know I'm going to be at 0 there. I know I'm going to be at 0 there. Okay. But what I really need to make sure you have straight is which way this goes, because people mix up tangent and cotangent. Okay. So tangent, and for the tangent one, I want to find these in between values at pi over 4 and negative pi over 4. Okay. All right. So instead of doing the usual ones, I'm just gonna add in here. Let me just put a few additional ones since I've already gotten those on there. If I do, let me just extend it here. If I look at negative pi over 4, okay, think about where that would be. That would be right here. Okay. And on a unit circle, that would be square root of 2 over 2. With a negative square root of 2 over 2. And tangent is y over x, so that would be negative 1. And a positive pi over 4 would be here, and it would be square root of 2, so that would be positive 1. So that just helps you get it straight, that when you're over here, you're up at 1. When you're over here, you're down at negative 1. Okay, so it's not a cubic function, but it kind of has that look when you do it. So it's going to wind up getting close to that asymptote and then having a little inflection right there at the origin and then continuing right here. So it's this kind of a look, and then that gets repeated over and over and over again. All right. So once you kind of remember how that works, you can get a pretty decent picture. We do a few more. Okay, and so there's our regular tangent. All right. All right, so what I wanted to do is once we got the tangent one on there, okay, let's think about, well, what would happen if we were trying to graph, and let's do this one in green. If we're trying to graph y equals 3 tan x over 2. All right, well, you remember with the cosine and the sine in order to figure out the new period and the phase shift, we took this part that was in parentheses and we wound up making a three-part inequality. Well, we're going to do the same thing here, okay? But the period for tangent is pi, and we're going to use that same restriction we used when we were looking at inverse tan functions, because that's where a complete section, the easiest place to see a complete section of the tangent graph. So what you can do is kind of like what we did with sine and cosine. You can take that part in the parentheses, and put it in between pi over 2 and negative pi over 2. And this is what we can do to figure out the phase shift and the new period, if there is a phase shift, and then figure out the new period. So when we go to solve that for x, we'd have to multiply everywhere by 2, which just knocks the denominator out. And so you wind up with this being negative pi is less than x is less than pi, okay? All right, so if you think about that a little bit, then this right here, from negative pi to pi, see where we are from negative pi to pi, that makes the period now 2 pi rather than just pi. So it's like we're going to stretch this out a little bit. And what we used to have happening between negative pi over 2 and pi over 2 is now going to be happening from negative pi to pi, okay? So that's one thing to keep in mind. And then once we do that, we're going to take care of the 3 right here. We'll be able to consider that. That's just going to affect how we stretch the graph vertically. So every output, every y, is going to be 3 times further away than the previous, okay? So I think I'll graph this, try to see if I can show it on a coordinate plane right below here. Well, I'll just go back and forth on it. So let me go ahead and get this one graphed. So we're trying to graph y equals 3 tangent of x over 2. So we set up the inequality to determine our new period and a phase shift, if there is one. And so everything used to happen between negative pi over 2 and pi over 2. And so now it's going to happen between negative pi and pi, okay? All right, now, so if you think about that, okay, and let me write down what I'm going to be graphing first. First, I'm just going to be thinking about tangent of x over 2. So if I look at from negative pi to pi, okay, so my starting and my ending point, halfway in between would be here. Okay, think about the what's really going to happen. If let me do an intermediate, sorry, let me do one more thing as an intermediate step. If we consider x over 2 and then do the tangent of x over 2, I think you'll see better the relationship. Okay, so if we think about negative pi, if we did negative pi in there, we'd have negative pi over 2. And so that's what we're trying to do the tangent of. And so then we wind up having the same value we had for negative pi over 2 here. It was undefined, okay? So negative pi over 2 was undefined. Well, the at negative pi on this graph, this right here is going to be undefined. Okay, and then 0 on the new graph, okay, when we do the 0 divided by 2, we're going to get 0. When we do tangent of 0, okay, we can do it again. We can think about it ourselves. It's going to be 0. Well, that's what it was before for the tangent of 0. It was 0, okay? So what this column right here is going to give us inputs like what we had on the basic tangent graph, okay? So if we plugged pi in, that would have been pi over 2, And pi over 2 on the original one, we know gave us an undefined tangent because pi over 2 was here, and that's 0, 1. And if you do y over x, it will be undefined. Okay, so what we're finding is what we used to have happening between negative pi over 2 and pi over 2 is now going to happen between negative pi and pi. So that's where our asymptotes are going to be. This is going to be our middle spot. And so guess what's going to happen when we break that down and look at the two in between? Okay, if we start here with negative pi over 2 and we divide by 2, we're going to have negative pi over 4. And negative pi over 4, we calculated before, was going to have a tangent of negative 1, okay, because negative pi over 4 is here, and that's where you'd have a positive followed by a negative, and it's square root of 2 over 2 divided by negative square root of 2 over 2 divided by square root of 2 over 2. So this is going to be negative pi over 4. And when you do the tangent of negative pi over 4, you're going to have a negative 1. Okay. So we're not plotting negative pi over 4, negative 1. We're plotting negative pi over 2, negative 1. Okay. And then pi over 2, oh, it moves if I move it too quick. Okay. It kind of slipped a little bit, so let me fix that. Okay, so then pi over 2, when we divide by 2, is going to be pi over 4. And the tangent at pi over 4, that's 45 degrees, the tangent is going to be 1. So we'll be up here at 1. Okay, and then you know the gist of the graph. It's going to come in, having approached the asymptote, have a little bit of an inflection, and then go down on the other side. Okay. All right, and then this would get repeated. If I went all the way out here, see that from pi, I have to go 2 pi, so I have to be all the way out here, okay, where 3 pi would have been, and that would have been another asymptote. See how I had a 0 here? This would be 0 at 2 pi. Here I'd be down at negative 1. Here I'd be up at positive 1, so it's going to repeat. It's just more stretched out because the new period was 2 pi, okay? The new period was pi minus negative pi, which is 2 pi, okay? So it just pulled it, it stretched it a little bit. All right, now what you see in green right now is really just the graph. And this, by the way, would have continued here. This would have been 1. This would have been coming in like so. Okay. All right. So what we just graphed in green right here is really just y equals tangent of x over 2. Okay. So now let's do the 3 part of that. Let's put a 3 on that. Okay. The 3 with sine and cosine is what affects the amplitude, and that affects like the vertical stretch or shrinking. So if it's a 3 out in front, we're just going to take all of these values and we're going to multiply by 3. So if we add in the 3 out in front to that, that's just going to mean this is still undefined, this is negative 3, this is still 0, this is 3, and this is undefined. Basically what that number out in front does is just stretches it. Okay. Darn it. Let me undo. See if it'll undo. I want that moved up. Let me see if I can move that up real quick. It just stretches the graph vertically. Let's see if I can get that back where it was. There, good. Okay, it just stretches the graph vertically. Okay, so let's get that graph now. All right, so where something used to be at 1, it's now going to be at 3. 3 times that. Still there. 3 times that. And so the basic look of it is just going to be more, still has to inflect, just more stretched. Okay. So this will be up at 3, still at 0, down at -3. So just this little bit steeper. It's really kind of hard to see the difference in reality. Okay. All right. And then this would also be up here at 3 coming in. And there'd be more if we saw it. So what you see in blue, that's y equals 3 tangent of x over 2. Okay. All right. So you can still set up the inequality. It's just when you do set up your inequality, when you take that and you put it in between, what you want to use is from -pi/2 to pi/2 rather than from 0 to 2 pi. Okay, if you do that, you wind up getting a full cycle. Okay, so the full cycle of tangent happens from -pi/2 to pi/2, and so you wind up then figuring out what the new starting and ending point would be. Okay, it's not a phase shift though. The whole thing was just stretched. The whole thing didn't get shifted left to right. It just was stretched. But we can see to start at -pi and the whole thing, the whole cycle doesn't happen until you get to pi. Okay. All right, let's try. Let's see if I can get down here. Okay. All right, let's look at one that does have a phase shift. Still a tangent one. So let me copy another blank. See if I can get a blank graph. Okay, so let me copy another piece of that. All right, and what I wanted to do is look at one more tangent one. So what if we were trying to ultimately graph y equals the tangent of x minus pi/2? Okay. So we know basically what tangent looks like, and we know that a full cycle happens when you go from -pi/2 to pi/2. So you're going to set up that inequality. And by the way, I'm not using or equal to on the ends because they're actually going to wind up being vertical asymptotes there. So you're not allowed to be equal to. Should have mentioned that earlier. All right, so if we add pi/2 everywhere, do you see how when I add the pi/2 to this, it becomes 0. This becomes x, and adding a pi/2 there, pi/2 plus pi/2, when you do that, don't think it's pi/4. Pi/2 plus pi/2 is 2 pi/2, which is pi. Okay? Okay, so 0 is less than x is less than pi, helps us to know our starting and our ending point. Okay, so tangent, usually everything happens from -pi/2 to pi/2. Okay, the usual period is pi. All right, well, if you'll notice, the period is still pi. You know, this is the starting, this is the ending point, so that is still pi. It's just that we're going to shift, and instead of having the original, see the original tangent had pieces that looked like this, right? Let me do the new one in blue. What's going to happen is we're going to start here at 0, and that's where we're going to have an asymptote, and at pi, and every pi after that. Okay, so we're just going to shift, and our new starting point is going to be at 0. See that pi/2? That's the phase shift. And remember, this was bx minus c in here when you looked at that general pattern from before. So see how that pi/2 is positive? So it's to the right pi/2. So it starts over a little bit further than it was. So the original one would have started at -pi/2. We're just going to move that all to the right. Okay, so what's going to happen is we're going to have that be where it hits the x-axis. And then it's going to do that in between these. and then have the 1 and the negative 1. Everything else is going to be the same. It just got shifted over. See how we can use that information to draw a pretty quick sketch? Okay, and this would keep going about like that. Okay, and then over here it'd be the same thing. So I've got to get my bearings. So this would be the halfway point. Then that would be at 1. This would be at -1. And there would be our tangent. And it would keep going. Okay. All right, so let me get the original one out of there so you kind of see what it's supposed to be. Erase. Okay. Okay, I want to get that black out of there. All right, so let me put the blue back in. So there was an asymptote, there was an asymptote, and we were winding up with what you see now. That's the graph of y equals tangent of x minus pi over 2. It just shifted the tangent graph to the right pi over 2. So rather than having this be at the origin, it was over to the right, and that was true for every single point. Okay, and then just think about it. You know, if you had like a 2 out in front of this, okay, that would just stretch everything to be 2 times further away from the x-axis. It's not a shift, it would just stretch it. So like instead of being at 1, you'd be up here at 2. Instead of being at -1, down here at -2. And you would have it more stretched out everywhere. Okay. All right, that's what that would do. And then think about this. If at the end I added, like, put a plus 1 there, what that would do is take every single, that would take, so say we go back to the blue graph, what you had in blue, which was the graph of this part right here. That's what you have in blue. If I did the +1 on that, what that would do is literally move every single point up 1 unit. It would be a vertical shift. Every point would move up 1 unit. And so the whole tangent graph would just be shifted up 1. Okay, and I won't keep going, but that's kind of the idea. Okay, so the same features. So if you have y equals a tangent bx minus c plus d, this still is a vertical stretch. We just don't call it amplitude, but it does wind up meaning that every output value is going to be 2 times further away from the x-axis. This is still going to be a vertical shift, an actual movement of the whole graph up or down, depending upon the sign of the D. You still wind up having your period and your phase shift being figured out in here, but it's not as simple as B being the period and C being the phase shift. There's a combination that happens, okay? So on this particular one, it had a phase shift. It moved to the right, okay? But since it was only an understood 1 in front of the X, the period was not affected. It still had that same period of 2, okay? Now let me back up. Ultimately, on this one, we were trying to graph y equals 3 tangent x over 2. So on this one, we didn't have a phase shift because the C is what causes a phase shift to happen. And we didn't have that, we didn't have the C part of that. So this one didn't wind up shifting, okay? It wound up being stretched vertically because of this, pulled everything to be 3 times further away from the x-axis. And then what actually happened because of that divided by 2 is it affected the period. Your new period was 2 pi. So it stretched everything out horizontally. It pulled it further away from the x-axis, okay? And so your old period that was like -pi/2 to pi/2 is now -pi to pi. So it stretched it. So it, so it was pulled horizontally. And then the number out in front, the 3, that took every output and just made it 3 times as far away. So it didn't shift the whole graph up. It just made each output 3 times further away from the x-axis. Okay. All right. I want to do one cotangent one. I don't think we need to do a whole lot of these. Let's say we had, say we wanted to graph y equals cotangent. Let's put a 3 in front of it. Maybe y equals 3 cotangent 2x. Okay. Now we didn't graph, we graphed cotangent in a separate video. Let me grab a graph paper here. Okay. Okay. So I just want to copy that. Okay. And let me get a graph over here. Okay, so ultimately we're trying to graph 3 cotangent 2x. Okay, that 2x there. All right, the 3 out in front is going to be a vertical stretch. So everything's going to be 3 times further away from the x-axis. And then inside here we have a b value. That's going to wind up affecting the period. With cotangent, that one wound up being a little different from tangent. It wound up being that everything happened between 0 and pi for that. Okay, so like when we were trying to graph just cotangent x. Okay. Cotangent, that's x divided by y. We wound up being undefined when x was 0. Okay, but then when we were at pi over 2, that's when we wound up getting 0. And then when we were over there at pi, we're undefined again. Okay, and then we wound up getting these in-between values. Let me make that a little smaller. Of pi over 4. So here it was undefined. We had an asymptote. Here we wound up having an asymptote. Here it was 0. And then we looked at pi over 4. And pi over 4 turns out to have a cotangent value of 1, because on the unit circle, the x and the y coordinates there would both be square root of 2 over 2. And then if you go around to 3 pi over 2, that's over here. Not 3 pi over 2, I meant 3 pi over 4. Okay. So I meant to go right there, which would be 3 pi over 4. That right there would have negative square root of 2 over 2 with a positive square root of 2 over 2. So when you divide the x by the y, you actually get a -1. So we wound up having it look like this. When we're at pi over 4, we're up here at 1. Pi over 2, we're at 0. And then at 3 pi over 4, we're down here at -1. And so it has the same look. It just goes the reverse. Okay. Let's see if I can get that back up. Slid on me. Let's see if I can get that back where I wanted it. Oh, darn it. Okay. So let me just clean up this asymptote over here. Sorry, I don't want to have to redo the whole entire video because I'm right here at the end. All right. So this winds up just looking like so. So pi over 4 wound up being 1, pi over 2, 0, 3 pi over 4. Okay, that's going to be -1, and then pi was undefined. Okay. All right. So that's the picture we had for the regular cotangent. Okay. So we know what the 3 is going to do. It's going to stretch everything. But what we're going to work on is this part. So when you're setting up your inequality for cotangent, you use the 0 and the pi. And you don't put or equal to because of the asymptote idea. What we're trying to figure out is if there's a phase shift and a period change. And so we wind up getting this to become 0 is less than x is less than pi over 2. So what that's going to do is that's going to mean that the whole thing, everything has to happen between 0 and pi over 2 rather than from 0 to pi. So everything's just going to be squished horizontally. Okay, so the same 5 points, the same concept, but it's like we're going to have 0 and pi over 2 here. Okay. And then halfway in between those two would be pi over 4. Okay. And then you'd have to think about halfway in between those two. Okay. And so that would be pi over 4 divided by 2. That would be pi over 8. And then halfway in between those two. Okay. So if you're between pi over 4 and pi over 2 right here, you have to cut that in half. Okay. So a good way to do that is to do pi over 4 plus pi over 2 divided by 2, to think about it like that. Okay. So that's going to be pi over 4 plus pi over 2. That's going to be, this is going to be 2, multiply the top and bottom by 2. This is going to be 3 pi over 4 divided by 2. So we're going to have 3 pi over 8. Okay, that would be 3 pi over 8. I'll work more on getting those 5 key points with you. Okay, so you understand how to do that fraction work. When you get the hang of it, it's a lot easier than having to go through all of that. All right, so what we're going to do when we graph this one ourselves is we're going to be using these for our x's. Okay, then we're going to be doing 2x, which is going to turn them into 0, pi over 4, pi over 2, 3 pi over 2, and pi. And so then we know what the cotangent of those are going to look like. Okay, we're going to have those same points. It's just going to happen. We're going to be plotting or finding that we're going to have an asymptote at 0 and an asymptote at pi over 2. Okay, so watch. I'm going to do it in red. So right here is going to be an asymptote. Okay, so everything's going to be scrunched. So it's half what it used to be, half as far as it used to be. So this point right here that used to be the x-intercept is now going to be over here. Okay. And then halfway between there, that's where the 3 pi over 8 would have come from. So it's going to be up at 1. Okay. And then over here, halfway between the pi over 4 and the pi over 2, right there is going to be at -1. And so see, it just kind of smushed it. So everything happened in a period that was just pi over 2. That's the new period. It's pi over 2. And see, the 0 would be the starting point, and the pi over 2 the ending point, and then you can get halfway, and then halfway between that and halfway between the others. Okay, and then this would get repeated. So what you would have is another asymptote. You know, you have an asymptote every pi over 2 on this one. And then your graph would cross the x-axis right in the middle of those. Okay, and it would be up at 1 on the left side and down at -1 on the right. And it would do something like that. Okay, and you could get it graphed. And so it would keep going like that. I won't keep drawing it. Okay, so that's the y equals cotangent 2x. Now, what would happen when we throw the 3 in there? That just stretches. What you see now in red is just going to be stretched. So the points that used to be at 1 are now going to be 3 times further away. So they'll be up here at 3. Okay, 0 is still going to be at 0, and this one's going to be down here at -3. Okay. All right, so we're going to wind up having it do something like that. And it really is hard to see the difference, especially when it's so small like this. But on tangent and cotangent, the amplitude changes aren't as obvious as they are with cosine and sine. You can't really see them because it's already really steep. Okay, especially when it's crunched, it's already really steep. So you don't see the amplitude changes. And so you just have to stretch every point to be 3 times further from the x-axis. All right, so that wasn't the best video I ever made, but I don't want to redo the whole thing. I'm going to do a video now where I just look at some problems where we're graphing variations of the different functions. So we'll get some more practice with this in a little bit. But hopefully this gets you at least started thinking about how to do it.